Hi guys, welcome to today's lesson. Today we are going to talk about integration of simple trigonometry functions. When you integrate cos, you are going to get sine x plus the constant. When you integrate sine x, you are going to get the negative of cos x plus c. When you integrate sec squared x, you are going to get tan x plus c. When you integrate cosec square x, you are going to get negative cot x plus c. When you integrate sec x tan x, you are going to get sec x plus c, which is the constant. The last one, when you integrate cosec x cot x, you are going to get negative cosec x plus c. So let's solve questions under the trigonometry functions. We have integral of 3 sec squared x plus dx. So this we are going to get sec square x dx, which is equal to, so integral of sec square x, we are going to get tan x. So 3 times tan x plus our constant, which is what? C. So that's our final answer. Let's go to number 2. 3 cos into bracket 4x minus pi out of 2 dx. So this we are going to get 3 integral of cos into bracket 4x minus pi out of 2. So from this question, we are going to apply substitution method. Here, I will let's say u equals 4x minus pi on 2. So du over dx will be equal to 4, because when you differentiate 4x, you are going to get 4, and when you differentiate constant, you are going to get 0. So our derivative of u is 4. This implies making dx the subject. We are going to get du over 4. Okay, so therefore our integral of cos into bracket, since we let u to represent this, we are going to get cos u multiplying, that's dx. So in place of dx, we are going to write du over 4. So du over 4, which is equal to 3 out of 4 integral of cos u du. So this we are going to get 3 out of 4 integral of cos u, that's when we integrate cos, we are going to get sine x plus c. So integral of cos u is sine x plus c. So we are going to get sine u plus c. So we are 3 out of 4 sine, our u here is 4x minus 4, pi on 2. 4x minus pi on 2 plus c. So that's our integral for 3 cos into bracket 4x minus pi out of 2. Let's solve more questions. Integral into bracket cos 3x plus 4 sine x dx. So this one we are going to get, so integral of into bracket cos 3x plus 4 sine x dx will be equal to integral of cos 3x dx plus 4 integral of sine x dx. Okay, so the integral of sine x, we are going to get negative cos x. By the integral of this, we are going to get 1 out of 3 into bracket negative sine x plus 4 integral of sine x is negative, cos x plus c. Integral of this, we are going to let u equals 3x. So this implies du over dx equals 3. So making the x the subject, we are going to get du over 3. So this implies integral of cos 3x dx is equal to integral of cos 3x. In place of the x, we have du over 3, which is equal to 1 out of 3 integral of, we represent 3x by u. So here we are going to get u in cos u. So 1 out of 3 integral of cos u, you are going to get negative of sine u, plus our constant. So we are going to get 1 out of negative 1 out of 3 sine, our u here is 3x. So 3x. That's why we're able to get 1 out of 3 minus sine 3x plus cos x. So our final answer is negative 1 out of 3 sine 3x plus 4 cos x plus c. Okay, more questions. Integral of 2 sine into bracket 5x plus beta bracket close dx. So this, we are going to get 2 integral of sine into bracket 5x plus beta bracket close dx. So this, I will let u be equal to 5x plus beta. That's substitution method. This implies du over dx equals 5. This beta here is a constant, so integral of a constant, derivative of a constant is 0. So 2 sine into bracket 5x plus beta bracket close dx will be equal to 2 integral of sine u times du over 5. That's here we make the x the subject, so the x will be equal to du over 5. Okay, so here we are going to get 2 out of 5 integral of sine u du. So 2 out of 5, integral of sine u will be cos u plus c. So 2 out of 5, u here was 5x plus beta. So in place of u, we'll be having 5x plus beta plus c. So this is our final answer. Okay, let's move on. Let's try this. Integral of cos square x dx. Here we are going to apply the properties of trigonometry, that's the trig identity. So we know that cos square x plus sine square x equals 1. 1 plus tan square x equals sec square x. Cos square x plus 1 equals cosec square x. Multiple angles, we have sine 2x equals 2 sine x cos x. Cos 2x equals cos square x minus sine square x, which is also equal to 1 minus 2 sine square x equal to 2 cos square x minus 1. So we are going to use this property to solve such a question. So integral of cos square x dx equals integral of 1 out of 2 cos 2x plus 1 dx. This was coming from the identity cos 2x equals 2 cos square x minus 1. That's 2 cos 2x equals 2 cos square x minus 1. So making cos square the subject, cos square x the subject, we are going to get cos 2x plus 1 equals 2 cos square x. So this implies cos square x equals dividing both sides by 2, 1 out of 2 times cos 2x plus 1. So that's what we have it here. Okay, so we are going to get 1 out of 2 integral of cos 2x plus 1 dx. So 1 out of 2 integral of cos 2x, as we solved it earlier, we are going to get 1 out of 2 sine 2x plus integral of 1, we are going to get x, then plus our constant c. So our final answer is 1 out of 4 sine 2x plus 1 out of 2x plus c. So let's solve this question. Integral of sine square x will also be equal to integral of, we know that cos 2x is also equal to 1 minus 2 sine 2x. So making sine square x the subject, we are going to get sine square x equals 1 minus cos 2x. That's 2 sine square x equals 1 minus cos 2x. Making sine square x, we are going to get 1 out of 2 into bracket 1 minus cos 2x. Okay, so here our sine square x is equal to 1 out of 2 into bracket 1 minus cos 2x dx. Sorry, forgot to break this. So we are going to get 1 out of 2 integral of 1 minus cos 2x dx. So we have our 1 out of 2 integral of 1. This means we have integral of 1 minus integral of cos 2x plus 8, sorry, dx, something like this. So we're going to get 1 out of 2 into bracket integral of 1 is x minus into bracket integral of cos 2x. We are going to get minus 1 out of 2 sine 2x plus c. So our final answer is 1 out of 2x minus 1 out of 4 sine 2x plus c. So this is our final answer. This integral of cos 2x dx, here you let u equals 2x. So this implies du over dx equals 2. Making dx the subject, we are going to get dx equals du over 2. So integral of cos, we represent 2x by u du over 2 will be equal to, which is we have 1 out of 2 integral of cos u. So our final answer is 1 out of 2 integral of cos u is sine u plus c. Our u here is 2x, which is sine 2x. So that's what we've gotten here. Okay, so we have integral of cos cube x dx. So here we are going to get integral of cos square x times cos x dx. So here, from the trig identity, we know that here that's cos square x plus sine square x equals 1. So making cos square x the subject, we are going to get integral. So in place of cos square x, we are going to get 1 minus sine square x multiplying cos x dx. That's making cos square x the subject. We are going to get 1 minus sine square x. So here, let u be sine x. So this implies du over dx equals cos x. Making the x the subject, the x will be equal to du over cos x. So this implies cos 3x dx will be equal to integral 1 minus, we said u be sine x. So you are going to get u squared times cos x dx. Sorry. In place of the x, we are going to put the u over cos x. So our answer will be integral of 1 minus u squared. Cos x will cancel cos x, left with du. So integral of 1, we are going to get u. Integral of u squared, we are going to get minus 1 out of 3 u cube. Then we add our constant c. So u was given, we let u be sine x. So we are going to get sine x minus 1 out of 3 u sine cube x plus c. So that's our answer. Okay, let's solve this question too. Here we are going to get so here that's cos exponent 5x dx. So here integral of cos exponent 5x dx will be equal to integral of cos square x times cos square x times cos x dx. So we are going to get integral of cos 2x exponent 2 x dx. From the trig identity, we know that cos x, that's what we've done here, cos squared x plus sine squared x equals 1. So making cos squared x the subject, we are going to get 1 minus sine square x times cos x dx. So let's say u be equal to sine x. This implies du over dx equals cos x. So integral of cos 5x dx will be equal to integral 1 minus, we know that our u is sine x, so u squared multiplying cos x. In place of d here, we are going to make the x the subject, which is equal to du over cos x. So in place of the x, we are going to write du over cos x. Cos x will cancel cos x, left with integral of 1 minus u squared all squared du. Sorry, I forgot the square. So simplifying this expression, we're going to get 1 minus 2u squared plus u exponent 4 du. Okay. So integral of 1, we are going to get u. Integral of this negative 2u squared, we are going to get negative 2 out of 3 u cube plus integral of u exponent 4, we are going to get 1 out of 5 u exponent 5 plus c. But our u equals sine x. So we have sine x minus 2 out of 3 sine cube x plus 1 out of 5 sine exponent 5x plus c. This is our final answer. Let's move on. Let's try this question too. Integral of cos 5x sine x dx. Here we are going to get this is very easy. What you have to do is you let u equals cos x. So this implies du over dx equals minus sine x. So making the x the subject, we are going to get du over minus sine x. So integral of this, we know that cos x equals u. That's u exponent 5 times sine x. In place of the x, that's we are applying the substitution method. In place of the x, we are going to get du over minus sine x. So here we are going to get integral, that's minus because of the negation, minus u exponent 5 du, that's sine x, we cancel sine x. So minus integral of u exponent 5, we are going to get, let's integrate it straightforward. So we are going to get minus 1 out of 6 u exponent 6 plus the constant c. 1 minus 1 out of 6 u, we know that our u is cos x. So we are going to get cos exponent 6x plus c. So this is our final answer.